All right, back for probability video 2. Chapter 7 was a short, teeny little chapter. We talked about probability distributions in table and graph form. Also in here, although it's not listed, was expected value, and then the very first question is on expected value. Um, and there was a formula. And then we saw 3 very specific distributions that had formulas. So this is kind of a formula chapter, but um, before we got to the formulas, we had these type of questions. As a fundraiser, the prom committee held the following raffle. They plan on printing 400 tickets. What should they charge to make an 80% profit margin? So the idea is the prizes are going to represent 20% of the cost, and profit's going to be 80%. There's a couple ways you can do this, but one way is to find the expected value per ticket, right? 20% of the value will be to pay for the prizes, and 80% will be profit. Well, this is how we show these probability distributions. X was some random variable. Often in these cases, it's how much we can win, or the value of a card, or whatever it is. And X is these values. And then px is the probability of those things happening. Remember, there's only one of those out of 400 tickets, so the probability is 1 in 400. How we calculated the expected value, remember, is we added a row to this table, which was x times the probability of x, because the expected value formula for any probability distribution is this little formula here, right? You take all the x's, multiply by their probabilities, and add them up. Remember, that's what that symbol, sigma, meant. And so I multiply by that, and I get some values here. That times that is 0.625, 0.375, 0.5, and 0.5. Then you add them up, and you get $2. So that means on these tickets, you should expect to win $2 worth of prizes, unless I did some of my arithmetic wrong. And notice that if I take that, that means 20% of the ticket value. If n represents the ticket value, 20% of the ticket value is $2. If I wanted to figure out what the ticket value should be to have 80% profit, then I'm going to just divide by the 0.2, and that ends up to be $10. They should charge $10. That's a tough. That was one of the tough type of expected value problems. Often we're just after how much we would expect to get on our investment. Next, I think, is, and again, pause the video if it's going too fast. 42% of students surveyed said they chip in for a horse and buggy ride. When you see that percentage, you're thinking you should see that as a probability or a percentage, and you should be, that should lead you in a certain way to which formula. Well, which ones have probabilities in them? The binomial one does, and so does the geometric formula. We'll get to that in a second. 6 people are surveyed. What is the probability that exactly one will want to chip in? Well, if we define this as a binomial situation where we're interested in the number of successes, and we're interested in how many people will want to chip in, then we've got n is 6. The probability of success is 0.42. As long as you pull the formula off your formula sheet right, this should be just fine. I'm going to change colors here. N was 6. X in this case was 1. Exactly 1. Probability of success was 0.42. Probability of failure is 1 subtract that, 0.58. And then it's just a calculator problem, right? Watch your style. And hopefully I managed to put this into my calculator correctly. 6 minus 1 is 5. You jam that into your calculator, and I got it to be about 0.1651. Closing sentence. There it is. Beautiful. And off we go. B. What is the probability of at least 1? That should ring a bell. At least 1 should make you think of the indirect method, right? B, the probability that x is greater than or equal to 1. I could figure out the probability of 1, the probability of 2, the probability of 3, and so on, but we know There's only one case that we don't want to count. That's if 0 happens, right? So in this case, it's the same formula, same stuff, except for x is 0, and then it's exactly the same. Jam that into a calculator, you should get about 0.9619, about, and a closing sentence. And notice that this makes sense that that's not a very likely thing to have happen. For C, what is the probability of finding the first chipper inner on the 5th person? This is the idea of we got 4 failures first, right? 4 failures first. This is geometric. And the geometric formula was this, where we're interested in the number of failures before the first success. Well, how many failures? Well, 4. 4 failures, 0.58 rather, excuse me, and jam that into a calculator, and you get about 0.0475, closing sentence. Last one, D. How long would you expect to wait? That's the other word for the geometric one, right? Waiting time. Expected to wait is the expected formula for the geometric distribution, and that is 0.58 over 0.42, which is almost 1. So about 1 person, right? 1 person before the chipper inner, before the chipper inner. Chipper inner. It looks like confidence interval, but it's chipper inner. Okay. Last one's a bit of a silly question, but I like it as a thinking question. It's this idea of writing your own question. Write a horse and buggy prom question that can be modeled by the hypergeometric distribution. So this tests whether you know what a hypergeometric distribution is, and it sees if you're creative enough to come up with a question that matches this situation. So hypergeometric, we got to use this formula, right? Or perhaps the expected value formula. Perhaps this one. Remember, hypergeometric is dependent events, and the probability changes between trials. Our situation can't be the same probability from time to time. So here's my example, although lots are possible. We're going to have, of 12 friends, 8 are female, 4 are males, 5 are randomly selected to go on a horse and buggy ride. What's the probability of majority are female? So the probability that X is greater than or equal to a majority of 5 is greater than or equal to 3, where we'd have to calculate these 4 things separately, or 3 things separately rather. They could have 3 females, 4 females, or all 5 of them could be female, where each of these calculations is this, where, let me get rid of that now, where here we have, this is the formula again. I'm going to copy it again. And what are these things? Well, A would be the number of possible successes, which is the 8 females. X is the number that we're interested, 3, 4, and 5 in this question that I made up. What else? We got N. N is the total number of people altogether, and R is the number we are selecting, 5, and then it's just a calculator exercise. Bit of a nasty one, but still pretty doable. That's it for Chapter 7. The last videos will be on the continuous probability distribution stuff, which we just took recently, so I'm hoping that should go fast. That's it.